Hello, my name is Hardy Hinton, and this is our Physics Project 1, and my job here is to describe the motion of the helicopter from its initial launch point. So, the motion of the helicopter that has been designed for the next Mars rover is designed to launch from its rest at t equals negative t, this point on the board, accelerating up into the sky, reaching a turnaround point where the helicopter will eventually come back down and land at a known little d distance horizontally away from its initial launch point. So, knowing that the helicopter is going to land a horizontal known distance d away, we want to wonder how much time the helicopter is going to spend in the air. So with that, we want to consider where the helicopter lands using expressions for delta x and delta y under these two equations. And knowing that it lands little d distance horizontally away from its initial launch point, we want to determine the vertical distance that the helicopter travels up the y-axis as well. Using our found delta y value of alpha divided by 35 over beta times d, we can determine how far away the helicopter's initial position is from the rover as the helicopter lands in both the x and y directions. Therefore, the motion of the helicopter goes from rest at t equals negative t to landing beta over 35 for alpha over 35 times beta times t or d away from its initial launch position. So then we know that the helicopter spends t equals square root over 3 over 2 times little d, the distance away, over beta, much time in the air. And so the helicopter lands d, comma, alpha over 35 times beta times d away from its initial launch point. Thank you.
From this problem, we start with the acceleration on the x-axis and the y-axis. And from the kinetic equations, we know that the integral of the acceleration gives us the velocity, and the integral of velocity gives us the position equation. From this, we are able to find the equation for velocity on the x-axis and the y-axis, but also the position on the x-axis and the y-axis. From there, we also know that the launch time is equal to t initial, which is equal to negative t. T is equal to unknown, and alpha and beta are constants that we know that don't have a number associated with them. We also know that t final will equal t, but since we don't know t, we need to find out what that is. Starting here, we have velocity at t initial is equal to negative t, and we're able to do this transfer big T to little t because big T has the units of seconds, and that is what we need for little t. So if we plug in negative t into our velocity equations for x, we get negative beta times big T over 2 plus the initial velocity, which comes out to the initial velocity is equal to bt over 2. For the y, we just get 0. Position, if we plug in t final for big T for t final, we're able to get our final positions on the x and the y axis, or the change in the x and the y. For this, when we plug it in, we get negative beta t squared over 6 plus beta big T squared over 2, which comes out to 2 times beta big T squared over 3. And since we know that the helicopter traveled d distance, we know that this is equal to d. For y, when we plug in big T, we get 2 alpha big T squared times 1 over 30 minus 1 over 42, which comes out to 2 alpha t squared over 105. And if we solve for t over here, we get big T is equal to square root of 3 over 2 times d over beta. And we can plug this equation into here for big T, and we get alpha over 35 times beta is equal to t. From this, we have to make sense of what is happening. So we know that little t d is the distance traveled on the x-axis, while alpha over 35 beta d is the change in y. So when the x-axis travels d distance, we know that the change in y, or uh, how high or how low the helicopter is alpha over 35 beta times d. Now, we can assume that the change in y is either going to be smaller or larger than d, because we have a big number, 35 times beta, and alpha is divided by this. So either alpha is going to be really big and beta is really small. We're going to get a really big d, or a change in y. Or if beta is really big and alpha is small, we're going to get a small change in d. But also there is circumstances where if alpha is 35 times bigger than beta, then we get a change in y that is equal to d. So from this, we found that if we can find t, big T, and we can plug that in, and we know that the bigger T is, the longer we're going to have for D, and the different change over alpha and 35B is going to be.
Hi, my name is Ali, and I will be presenting the reflection for today's project. Um, this problem we have, it's like, it's something that we never really have done ever before. And basically, what this tells us is looking back at this, we would have never been able to solve this on our own without any general knowledge about physics. And the way how we have gained that is by going through our classes and labs, as well as homeworks and assignments, which has made us build up this general knowledge about sense making, problem solving, as well as understanding physics in general. What this has done basically is that it made us understand problems that are this complicated into just making it's just simple. Um, one of the references where I could state that made us understand this kind of problem are from our homeworks, labs, as well as our uh, class activities that we've done in the past. One of the homeworks was actually the homework two, where we had to basically calculate our friend standing on top of a cliff, holding a ball and just at initial velocity at zero and just letting it go and seeing and determining how fast was it going and where exactly did it drop off. The other activity was during our lab in week three, where we had to basically uh, we had a slide and a metal ball we had to put at like certain distances wherever you wanted and just let it go with initial velocity at zero, and just the moment it just went off the table, we had to calculate basically the starting point where it was on the air until it went and touched the ground. We also had to take calculating kinetic energies in classes and so much other things. And basically, what has that done is boost our general knowledge, our sense making, and help us to understand completely how we ended up with a situation like this and how we could basically solve a problem this confusing. Thank you.